Hi, my name is Lisa Richter. I'm the Director of Industry Outreach and Growth for CSIA. Welcome to the Masterclass. Before we get started, a quick word about CSIA. Maybe you have heard of CSIA, but if you haven't, all you really need to know is that CSIA's mission is to help system integrators build better businesses. How do we do that? Well, for starters, we have a team of volunteer SIs who have crowdsourced a best practices manual to help SIs scale their businesses. In fact, the BP manual regularly reviews and updates the manual and is currently on its sixth edition, and the committee is already planning for the next version. For those companies that want to take these best practices to the next level, CSIA also offers a certification program that includes a third-party audit. Many companies find that this audit is extremely helpful for helping them understand their businesses and how to scale. CSIA is also helping system integrators grow their businesses with a new learning hub, which is an online platform with content and playlists that have been sourced and vetted by seasoned SIs to help our members get their teams up to speed quickly. Think of it like Spotify. All the content is there, but imagine having a personal DJ who spent over 20 years getting to know your preferences and tailoring the perfect playlists for you. With thousands of qualified integrators and suppliers, the CSIA Industrial Automation Exchange helps SIs, industry suppliers, and manufacturers connect and do business. For SIs and partners, it provides a platform to support your content and SEO marketing efforts, position yourself as a thought leader, and nurture prospects during their complicated buyer's journey. If you are not currently a member, now is a great time to join. Membership provides you and your entire team a full lineup of virtual events and other resources, from accounting to sales to operations to training, 365 days per year. It also means you and your team can attend the CSIA conference because this annual in-person event is members only. If you want to just get a flavor of CSIA and its members, I encourage you to listen to the Talking Industrial Automation podcast. CSIA members talk all things industrial automation, and it's a great way to hear what your peers are up to. One last housekeeping note before I turn it over to today's speakers. If you have any questions during the presentation, please use the Q&A feature in Zoom. That helps us stay organized. The session is being recorded, and you will get a link to the recording in the next day or so. At this time, I'm going to turn it over to today's speakers, starting with Hal from Graybar, who is the sponsor of the event. And yeah, so take it away, Hal.
Thank you, Lisa. Good morning, everybody. As mentioned, my name is Hal Chastro. I am the National Director of Industrial Automation for Graybar Electric. And today we are honored to be able to participate in the CSIA Masters class, both myself being in Graybar and Snyder Electric. At Graybar, we're a leading North American distributor of industrial automation, electrical, comm data products, and we have a network of over 325 locations that serve over 146,000 customers. And just to kind of wordplay, we feel that everything runs smoother with Graybar and Snyder Electric. And so now it's my pleasure to introduce today's speaker, Christine Bush. She is the director of the Robotics Center of Excellence for Schneider Electric in Raleigh, North Carolina. And she's a seasoned industrial professional with nearly 30 years of experience in automation and system integration. She began her career with AFG Industries in Spring Hill, Kansas, where she managed DCS integration and maintained high availability systems on a 24/7 manufacturing environment. Her journey continued through systems integration roles with IBT and QSpec Solutions, where she specified in pharmaceutical batching systems. Christine later joined Schneider Electric, where she has held leadership roles in application engineering, engineering management, sales, and marketing. So today she leads Schneider Electric's Robotics Center of Excellence, driving innovation at the intersection of robotics, automation, and digital transformation. So it is my pleasure to introduce you to Christine Bush. Christine, take it away.
Thank you, Hal. I appreciate those kind words. As Hal said, today we are going to talk around digital twins, how they came to be, how they are a powerful tool today, and where we're going in the future with digital twins. So we have to thank NASA for the digital twin technology that we use today. They started in the 60s through the 70s using a simulation tool for the Apollo missions and to troubleshoot any issues they had with those Apollo missions. From there, in 1991, the book Mirror Worlds revolved around the concept of the real world mirroring, a digital environment. Then in 2002, Michael Greaves introduced the twin concept at a SME conference. And then right back at NASA, John Vickers coined the tool digital twin. And that's how we refer to this space today, as a digital twin environment. It became prevalent in the manufacturing and aerospace industries as early adopters for twinning technology. And today we use it in many, many different ways in many different markets. So how are we using twins today? In my space, I do work for Schneider's Industrial Automation line of business. So the majority of what I'm going to be talking through today is aligned with automation and control. So we use it in manufacturing, from a production line design, line simulation. We also use digital twins in the warehouse logistics space, doing layouts, route optimizations, any simulations on packaging durabilities. Are there any funnels in the flow train to design those out? And of course, the aerospace and automotive industry definitely uses it today to extend and review life cycle management. I would be remiss if I didn't mention the power side of Schneider's business, where we use digital twins in smart cities, where we're looking at energy uses, looking at urban planning, and simulating traffic flow. So, right out of the gate, what is a digital twin and how do we use digital twins today? So first and foremost, I think everyone has used a flavor of a digital twin in simulating a machine or a process line in manufacturing or an automotive space. From there, the next most used area with the digital twin would be the emulation, really stressing out the processes and the connected products to the twin to make sure that whatever we are delivering to the field is going to function. But are you using it as a sales tool? So we have sales animation that will add a great layer to your business. I know it's a great tool for our sales teams. It's also an engineering tool in many different ways to test upstream, downstream connectivity at a machine level, to connect to IT systems above, into the OT systems as well. Then I think we have a missed opportunity, and one I'm focusing a lot of my energy on, and that is the operator training. Are you empowering and training the operators for the systems you're putting in the field? Or are you turning it over to the end user for the end user to train the operator? So I think this is a huge opportunity for all of us. And then I think the next layer is using it in real time, using a digital twin as the proverbial DVR. Stop where an event has occurred at a machine on the manufacturing floor, review it to see if we can understand exactly what is happening in the moment where an event has occurred. So I want to dive in a little bit in the simulation. This is showcasing AMRs, moving loads around in and out of robotic cells, and simulating warehouse space as well. So this is one way to utilize a digital twin, and it gives a view of the entire floor space. So you can look at one side of the warehouse space versus the other side of the space. You can slow down so you can really tell what is happening in the manufacturing space, to make small changes, and then you can speed it up to make to make sure that you're hitting flow within a space from a simulation point of view. So this video will speed up here in a second, and you'll get to see what I'm talking about from speed up the process to really understand what that flow can be for an end user. The next space is, are you using it as a sales tool? There are many different audiences that I know you're interfacing with. You could be interfacing with a warehouse space where manufacturers are storing product, end users are manufacturing products. And this is just a quick overview of what could be with the floor space that they have. So it is a great opportunity for our sales teams to get out and showcase what could be a view of their floor. We also use it at a machine level. So we can do a high level simulation, trying to understand picking widgets off of a conveyor in a certain order, placing it on another conveyor in a certain order. And in this simulation, the engineering team was under the impression that they needed 4 Delta robots. And through the simulation, we find out that we can drop the 4th robot, take it down to 3 robots. We still have no losses of pick and place. And then we also can take it down to 2 to see if we're really utilizing the space as well as the money that they have for a capital project. So when we start testing with the 2 robotics, we start to see that we're missing picks for the application. So this is where we get in and we understand that from an efficiency perspective, we can meet the job with only 3 Delta robots in the simulation. And so we're reconfiguring the digital twin for those 3 robots. We also can test belt tracking to see if that can help. We can test out widening the conveyors to see if that will help. And then we can really put forth to an engineering team a defined overview of what the system should look like from an efficiency perspective. So this digital twin demo is going to finish out here with the final product of the widened conveyors and the 3 Delta robots for the final run. So it's also an engineering tool, and a digital twin can be utilized with wearable technologies, where it's a goggle type environment, whether it's like Google glasses, Ray-Ban glasses. We also can utilize twins on the road with utilizing our smartphones today. Of course, we also have engineering workstations where we can utilize the simulation and emulation software from our desktops or laptops. The best thing is to be able to emulate a process on a floor. In this case, it's a warehouse space, and we're looking to see if we're moving totes around efficiently, if we have any jam locations with the process, so we can go ahead and make changes before we ever buy any materials. The other thing is from a controls engineer, you guys always know that the controls engineer, we're the last ones to take the floor. So we're waiting on mechanical installations, electrical installations, and once they turn it over to us, we get to deal with all the changes. But with digital twins, if the conveyor has to be moved a foot or lengthened, we can be modeling out that while we wait, and that's adjusting our code. So emulating and simulating the process is very important to all of us. I talked about this being the area that I think is most overlooked, and maybe a value proposition for you as systems integrators to look at bringing value to your customers by creating training modules for your customers. Because what would a world look like if we could turn over training modules with various scenarios that the customer has already told us about, and to create those sim modules for the operator so that the end user can empower the operator and they can get out on the line and be prepared for anything that might happen on the line, instead of it happening in the moment and a new operator may not act as quickly and efficiently as they could if they had proper training. So if there's one area that you're not already doing today, take a note. This could be a great source of revenue for you, and you will be introducing yourself to a new area of an end user, the safety and health, either director, VP, etc. All end users have them. And then it's the real-time view, being able to look at a process in real time. This is baggage handling in a European airport, just for context, the safe and unsafe side. And this gives us the ability to see if there are any problems in the process, to be able to zoom into any area of the process and to be able to really understand in a quick amount of time what needs to be done to course correct or fix a conveyor belt, replace a sensor, rectify a jam situation. So I think the real time value here is really another key area for us. And I don't know that our end users are using this real time. I think they're relying just on alerts on HMIs. To be able to use this as a DVR in real time, I think is going to be a key area. I attend a lot of trade shows, and one of the things I'm seeing from end users ask is do we have digital twin simulation and emulation capabilities? And for you to be able to answer for your businesses, yes, it tells me that they want to make sure they're having a more efficient project and they're actually getting what they have requested out of a system or a machine. So one of the things I wanted to, let me forward this real quick. One of the things I wanted to jump in real quickly is what are we doing with digital twins in order to make it easier for controls engineers? And one of the things that I see is the use of AI technology inside the programming environment as well as inside the twinning environment. So just to be able to ask a simple question, this one I just threw in because I do have robotics under my responsibility. I just real quickly typed in, hey, can you create a code to home a cobot using a very specific library? So, with AI capabilities, we had the ability to use the tool, test the tool, and it created code for us, and it provided references of what libraries it used and where it pulled the information from. The other thing we can do is just simply ask, hey, can you show me what the diagram of this code looks like? And it can create a nice flow of the code that it just generated. Because we all know jumping into someone else's code becomes a little trying. And so to give us a head start, this diagram can help us move through troubleshooting and or understanding someone else's code, in this case, an AI interpreter. So from here, I know everybody is probably concerned about, oh, how do we implement it, and what are the real challenges that we see with implementing digital twins. So we know that implementing a digital twins, we're going to have a lot of data, and we need to bring in high quality data at a real time. And we're also bringing it in from a lot of different systems if we're at a manufacturing floor or a warehouse logistics space. So we know we'll be connecting up to legacy systems. Today we have IoT devices that can go directly into a system without the necessity of having a PLC or PAC control and discern the information coming in. There's also a lot of systems integration that has to occur from the IT level to the OT level with digital twins, because we don't just stop at simulating and emulating on the OT side. We also need to connect ERP systems, MES systems. So to be able to interface both IT and OT systems through a twinning environment is a must these days. I think one of the things that we struggle with systems integration is a lack of standardized data from the IT to the OT side. So that is something to note and pay attention to as we work with digital twins in real time. From there, with real-time processing, we know we need a robust infrastructure. There's a lot of data, both on the IT side and OT side. It needs to be robust. We need high-speed networks. And then we also need to interface with the localized edge computing. From there, we all know the more connected we are today, the more cybersecurity risks. So what are we going to do to secure data transmission? Who's going to have access to these digital twin environments? We know that digital twin environments can be high investments. There's skilled personnel that needs to be involved with a digital twin, both at the IT and OT side. We have to think through many models of what can happen when we are generating a twin at the manufacturing floor at a machine level. And then just the fact of connecting all these systems adds to that layer of investment that needs to be made. From there, are you going to have a challenge of organizational resistance? We all kind of have a tendency to fear change, but we get over that pretty quickly and we embrace that change. So I think this is something that we need to get into early on with a digital twin environment. From there, a standout of just lack of standards. We have an absence of open standards. So as you're trying to take advantage of different types of technology that we have today, is it all from one vendor? Is it from multiple vendors? So how are we bringing all of these systems into a digital twin? So future space open twins may be an area of focus. Maintenance. I talked a little bit about just the controls engineers are the last group to get to the manufacturing floor or the warehouse space, or honestly at a machine level as well, to get our hands on putting code in and discerning functionality of the system that we're working on. But as we work on systems and change things in the field, we need to make sure that we're maintaining the digital twin. So if something fails in the field, or we determine that performance from the real world tells us we need to make a change, we also need to be adjusting models. And that includes software updates and hardware calibrations as things wear through time. So what are the solutions for all these challenges? Well, from a data and complexity layer, just having an implementation of some type of data governance is really needed in order to have a successful digital twin implementation. I just showed a little bit of AI tools that we're starting to embed in our digital twins and our programming environments. So utilize that AI-based tools. I know right now we're kind of on the edge of how are we using it for good? How can it be used for bad? So right now, I would highly suggest on-prem AI-based tools versus the cloud tools. Then there's, again, the integration from the IT to the OT side. So utilizing and adopting open AI APIs, as well as implementing standards such as MQTT, OPC UA that has embedded cybersecurity features within those standards. Real-time processing. Are we utilizing cloud platforms to scale for what we're trying to do with the twin environment? How are we implementing that edge computing in the real time? And use of event-driven architectures all can help us with real-time processing. So from a cybersecurity area, end-to-end encryption. We see it in our daily lives, just in our emails and the way we communicate internally to our organizations, to externally to our organizations. There is a all-time high when it comes to adopting end-to-end encryptions in many facets of our business, and that will extend into our automation and control environment. Also, just real-time monitoring to see who's connected, who is not connected. Offer regular audits. Update security protocols. Then from an investment perspective, I think this is a one to think through, because it can be very overwhelming to implement a digital twin from an investment perspective. So start small. Start with one line at an end user's facility. Start with one machine if they're an OEM. Then start scaling from a small machine to a larger machine. Go from one line in a manufacturing process to multiple lines in a manufacturing process. Same with the warehouse space. And then utilize twinning as a service to cut some costs. From this integration community, I see this as potentially another great area for you to potentially drive revenue, is to offer customers where you focus, whether it be food and bev, whether it be logistics, whether it be pharma. Can you offer some of these tools that we've talked about as a service for the end user? From an organizational resistance perspective, involve the stakeholders early. They're the ones that potentially are going to make and break a full implementation at a digital twin. So we want that early buy-in. We need to communicate the benefits, such as empowering the operator with twinning training sessions, and celebrate all the wins. That way the entire end user organization sees the value in what a digital twin can bring to them. From a lack of standards, choose vendors that support interoperability and align with emerging standards. This is a way to make sure you have flexibility with taking advantage of the technology that's coming at us so quickly these days. Otherwise, you could be stuck with a single logo solution. Not that that's bad, but again, with technology changing, being able to have the ability to have open protocols to take advantage of what's coming at us, I think there's a real advantage there. And then from a maintenance perspective, implementing AI and machine learning to retain and adapt the models for the changes that are on the floor. So through both of the challenges and solutions, I did not talk about our biggest challenge that we have. And we're all seeing this. We have a skilled labor shortage. And what Deloitte is showing is that by 2030, we'll be up over the 2 million mark. I honestly think with some of the information that I'm seeing, we'll be well above the 3 million mark, where we have openings for skilled labor, and we will not have anybody to fill those openings. So this is where utilizing AI technology, digital twin technology to do more with less will be key for survival for the manufacturing space. 14% of Gen Z would consider working in the industrial space, and 27% of Gen Z just wants to work in technology. So what can we be doing to overcome our workforce problems? We can be investing in training programs. We can be taking surveys of the employees that are already are part of an organization to see where they may be motivated to skill build and do a career change and get involved with industrial automation. Also, partnering with the universities is really, really key to influence emerging talent coming out of these wonderful universities. So, sorry about that. I'm at the end of my presentation, but there's one thing to be said about digital twin. Digital twin technology is a very significant resource that you can use as an integrator to influence the projects that you're working on, to influence end users with this floor space that they have, influence OEMs with the machines that they have. And we can look at the entire life cycle from the manufacturing floor to a machine, looking at what are the current system requirements. Are we doing a new design? Are we working on a redesign? Definitely tools from an engineering perspective. It saves us valuable time when it comes to commissioning on site. We can do a lot of it virtually today and less time on site. We can ramp up to full production in an extremely short amount of time versus when I originally got into this space. And then just a level of production from an efficiency of product going out the door in a timely fashion, as well as level setting and taking up the level of the quality of the product going out the manufacturing floor space. And then, of course, optimizing anything at the machine level, at the floor, from a retrofitting perspective. And this takes me to the end of my presentation. I do want to open it up for questions and to have an open dialogue with everybody on the call today.
Hey, Christine, one of the questions in the Q&A was how do you obtain the models of the physical machines in a cost-effective manner?
That is where starting early is going to be the best approach. So if you're today not creating a digital twin for a machine, if you're not creating a digital twin from like a process OEM perspective where you have multiple stations, then you're already behind. And I know end users are concerned about potentially investing in digital twins at their sites, but I would say they need to invest now, because yes, it can be more than what they have initially scoped the amount of funding for from a capital project. But we need to be having these open conversations with end users and OEMs from the systems integration community, because the more we wait, the more work that has to be done. So that start small, start with the first machine, and then expand it to the second machine. And before you know it, you'll have the complete floor. If you have to start from scratch to do a complete floor, yes, the overhead is going to be quite substantial, and there will be a quite amount of time to have a complete simulation at the factory floor. Once you have it, the return on investment is, now that I have it, can I move these machines around? Can I tighten, remove some of the miles and miles of conveyor that we originally designed with? Can we shorten the space up and use AMRs or AGVs, so that we're utilizing the space that we have today, and it could be influencing an end user to modernize their current facility versus going in to a greenfield situation, building a new plant from the floor up.
And then the follow-up question is, if I have a single machine and I want to do a digital twin, simulate the different aspects, is there a brief walkthrough or overview you can give of what's needed and what steps would be used to obtain the digital twin from the PLC?
I don't have any models of that in the presentation, but it is something that we certainly can have a sidebar conversation on, and I can get engineers to work with you, and we can have a more in-depth conversation around everything that you'll need. Usually we start at a very high, you saw those four Delta robots. It wasn't a very pretty twin, but it was functionally, we wanted to see functionally what we could do. It's working with the CAD designers to bring in SolidWorks, working with connecting with all the PLCs, the controllers from the robotics, and bringing that into the twin environment. You're on mute.
Just try not to overstep you. And from the chat, I apologize. There was one other question of, they've been told that a true digital twin is more than simply a simulation, and they need to, for example, be able to read physical inputs from the PLC and mimic outputs in lockstep with the actual physical machine. Is this accurate?
Absolutely, because simulating is while you can be simulating in, let's say, the PLC environment, you don't necessarily have to. That would be an early step. Utilize the simulation tool that's available inside the PLC. Then start getting that connected, that data pulled into the digital twin. And the emulation space is very, very important, because it's really stress testing the functionality of the speed of a robot, the processing power that a processor has. And you can see that early on, before you get everything on the machine, or every piece of equipment on the manufacturing floor. You'll be able to stress test those PLCs to ensure that they're sized correctly.
That's all the questions I see in the Q&A in the chat. Is there any other questions that Christine might be able to address for the group?
One, none of my business, but I think when we were chatting before the thing started, there was a question about Aviva and how Aviva works into the whole ecosystem, et cetera, et cetera.
Thank you for the question. Schneider Electric can be a very complex beast. So This digital twin technology at a machine level at a warehouse manufacturing floor is a Schneider Electric offer. It is not part of the Aviva offer. I mentioned early on that Schneider Electric is a large organization, and I will say this not just with Schneider, but across many of my competitive friends. There are many digital twins for whatever the, the whatever you're trying to plan out. So for us in the industrial automation space, this tool is for Schneider. On the power side of our business, monitoring circuit breakers, understanding electric flow, power factor, that's going to be a separate twin that's not connected to the PLCs and the sensors that are making up, the control side that we're trying to twin out and model.
Okay, and I do have one more question. Christine, if people want to talk to you or somebody else at Schneider about this, or Hal, if they want to talk to you about things, how do they contact you? Are you on LinkedIn? Do you prefer email? Are you stealth?
Yeah, I am on LinkedIn. Email's probably the best way to get a hold of me. I don't have it on a slide, but if you can see my name in the chat session, is christine.bush@se.com. And I can get back to you. You can also, if you know who your Schneider Electric salesperson is, or your Gray Bar salesperson, you can tap them on the shoulder, and they all, Hal knows where I work, so he can track me down quite easily. But yeah, don't hesitate to send me an email at, again, christine.bush@se.com.
I put both in the chat, and Christine, there were 3 other questions in the chat.
Okay.
How does digital twin work together with Namer, NAMUR, Namer's Asset Administrative Shell, AAS?
I don't have a specific answer for that. I'm gonna have to do a little bit of homework and
Okay.
get back. So I don't know if that is a question that can be forwarded to me, and then I can.
Yes, it's in the chat, so we'll grab that.
Perfect.
And I'll grab it. And then how can we start offering this service for our clientele? Where do we begin?
I think the beginning is just going in, knowing that, and having an open conversation with your customer that you highly advise the efficiency of utilizing a twin to be able to help train operators in the field in a future state, help model out the entire flow on a manufacturing floor space or warehouse logistics space, even pharmaceutical. I mean, the options are endless as far as segmentation and industries are concerned. But I think it's having that open conversation and showing to the end user OEM the value that the twin has. And again, it's more than just simulation and emulation. It's the value that we can bring to the operator. It's the value that we can bring to help troubleshoot in a faster perspective by having that twin real time at the machine level or at the floor level, so that you can use the technology to be that DVR to stop, back up, look, see exactly what was going on when there is an event in the system.
And then last question I see in here right now is, are there any good resources for seeing an example of implementing a digital twin on a small machine? Perhaps something open source where I could review the code.
Yeah, we certainly can put together some information for that, so that could be another one that gets forwarded to me. I can have one of our application engineers sit down and go through the process with our tool and or the methodology, because the methodology will be very similar across multiple logos.
Perfect.
Okay. I think then maybe we have exhausted all the questions. So I'll do my little wrap up here. My colleague is going to put up a little slide for me. All right. So on behalf of CSIA, I would like to thank our speakers, Christine and Hal, for this informative discussion. Also, thank you to Graybar for sponsoring this event. And of course, thank you for attending. Be sure to bookmark the CSI events calendar so you don't miss any upcoming events. And that's a wrap. Once again, thanks for joining us and have a great day.
Thank you.